All right, so this video is going to start on page 28, so conservation of energy. So we've been talking about potential energy, we've been talking about kinetic energy. So now we're going to talk about total energy and conservation of energy. So total energy is the total energy of an object is the sum of all the types of energy that object possesses at one time. So total energy equals basically your kinetic energy plus your potential energy. Okay, so an object can have both kinetic and potential at the same time, or one or the other. Okay, so there's always going to be some form of energy going on there. So the law of conservation of energy may change forms, but it cannot be created or destroyed. So it can switch back and forth between kinetic and potential. So like think of it like a roller coaster. Okay, when you go to the top of the hill, you're building that potential energy up. And then once you go down the hill, your potential energy is going down, but your kinetic energy is going up. Now, you're not actually losing energy, you're just transferring it between two different forms. So the key thing here is total energy initial equals the total energy final. So whatever total energy you had in the beginning better be the same you had in the end. So we can apply the law of conservation of energy to kinetic energy and potential energy transformations. So basically what that means is there's going to be a potential energy initial plus a kinetic energy initial equals potential energy final plus, kinetic energy final. So PE plus KE equals PE plus KE. So our example, what velocity will a 2 kilogram mass have when it strikes the ground if it is dropped from 15 meters? Okay, so here's my trick when you want to know when to do the whole PE plus KE equals PE plus KE. So anytime you have two different heights, okay, so anytime you have two different positions, so you have a ball that's 15 meters up, and then you have a ball hitting the ground. So it's got two different positions. So that means there's going to be two different types of energy going on at one point, and then different types of energy happening at another point. So if I have my object, so let's just say I drop the ball. Okay, it hits the ground. So we'll just say the ball starts up here at 15 meters. So when it is being held at 15 meters, there is PE plus KE up here. And then there's PE plus KE down here. Now this is going to be the initial side because that's before you dropped it, and this would be the final. So we're going to look at our equation. So PE plus KE equals PE plus KE. Now I always do my left side as my initial side, and my right side is my final side. Okay, so when the ball is being held at 15 meters, okay, it's just being held there. So it's got potential energy because it has height. Now, before it is dropped, it's just being held there. So if it's not moving, that means there is zero kinetic energy. Okay, so you can just mark that off and put that as a 0 because it hadn't started moving yet. Now, when it hits the ground, it's got lots of velocity because that's when it's moving the fastest. So it's definitely got kinetic energy. But when you hit the ground, you no longer have height. So that means potential energy has now gone to 0 when it hits the ground. So this one really becomes PE initial equals KE final. So now we're just going to plug in the equations. So potential energy is mgh equals kinetic energy, which is 1/2 mv squared. Now, if you look, they both have something in common on both sides. They both have mass on both sides. So if they are on both sides of the equal sign, that means it does not matter. We can go ahead and cross those off because they would just cancel out anyway. It wouldn't matter. So this really becomes gravity times height equals 1/2 v squared. So you can see how it started off kind of complicated, but then it just boiled down to this more of a simple equation. So gravity is 9.8. My height is 15 equals 1/2 v squared. And you can solve for v now. So get V by itself and then square root both sides. So my V final comes out to be 17 meters per second. Okay, so moving on to the next page, page 29, says a 0.25 kilogram ball is thrown vertically upward from the roof of an 18-meter high building with a speed of 16 meters per second and just misses the building on the way down. What vertical height does the ball rise above the ground? So I'm going to draw my building. Okay, the ball is being launched up, being thrown up, and so I want to know how high did it actually go. So your points are A, here, your initial is when you threw the ball up, so when you're standing on top of the building. Okay, and then point B is your final, okay, because that's when it reaches the top of its path. So that's how we're going to label it. So we're going to do our PE plus KE equals PE plus KE. So left side is going to be my A side, right side is going to be my B side. So on the left side, at point A, I do have potential energy because I do have height. And then I also have velocity right there because I actually launched it up. Okay, so I'm not dropping it. I actually threw it up in the air with the velocity. So I have both potential energy and kinetic energy. So I can't cross off anything there. Now, when you get to the top at point B, you definitely have height. Okay, so you definitely have potential energy. But what happens when you throw a ball up? Okay, it's not going to just keep going and going and going. It's got to stop. So once it stops at the top, that means kinetic energy is now 0. So that is one we can mark off. So this becomes a PE plus KE just equals PE. So now we can plug in. So mgh plus 1/2 mv squared equals mgh. Now, mass is common in all three of these, and I have mass on both sides equal sign. You can only cross off mass if it is on both sides of the equal sign. Okay, so if I were doing something like this, like F times D equals 1/2 mv squared, okay, if you noticed, mass is not on the left side. Okay, so since it's not on the left side, you cannot cross that M out. Okay, so just watch out for that because crossing off the M's on this part of the unit, okay, can kind of lead to issues in the previous parts because now you just assume you can cross off all masses. But you can only cross off all masses if they're on both sides. So I can go ahead and cross these out. So this becomes GH plus 1/2 V squared equals GH. So at point A, gravity is 9.8. Okay, and this was an 18-meter high building. So my height is 18 meters. Plus 1/2, my velocity is being thrown up at 16 meters per second, and that's squared, equals G, which is 9.8, still gravity there. And then now you can leave height as H. And now you just got to solve for H. So I get a height of 31.1 meters. Okay, so that's the answer for that one. Now part B, it says, with what velocity does the ball strike the ground? Okay, so I'm going to draw this again. Okay, so the ball gets thrown up and then it comes down, hits the ground. So again, it started at point A and then it ends at point B. Okay, so those are going to be my two scenarios that I'm looking at. So we're going to do our PE plus KE equals PE plus KE. Okay, so we've already established at point A, okay, it did have height, it did have velocity. Okay, so I could not mark off any of those potential or kinetic. Now, when it hits the ground, okay, it definitely has kinetic energy because it's hitting the ground with a velocity, hitting it with a force. But when you do hit the ground, your height goes to 0. So now potential energy is at 0. So you can just cross that one off. So we can go ahead and do the skip. We can go ahead and skip the whole crossing off mass parts. So this becomes GH plus 1/2 V squared equals 1/2 V squared. So now I get to plug in. So gravity is 9.8. Height 18 meters. Plus 1/2 my 16 squared equals 1/2 V squared. Okay, so now I just got to solve for v and then square root both sides. So I get a velocity of 24.7 meters per second downward. Just remember, because velocity is a vector, okay, you could either say negative 24.7 meters per second, or you can say 24.7 meters per second downward. So remember, basically what this is stating is that whatever energy you had at point A, whatever total energy you had, both potential and kinetic, is going to be the same energy you have here at point B when it hits the ground. Now at point A, you have both potential and kinetic, but at point B, when you hit the ground, all that energy shifted to purely kinetic. Versus at point in that question A up here, whenever that ball reached the top, whatever total energy I had at point A is now all been converted to just potential energy at point B. So we didn't lose or gain energy, it's just shifting back and forth between potential and kinetic. Okay, so like if I launch something up, so this is just like a example. So let's just say from the ground. So from the ground, I have 0 potential energy, and I have all kinetic energy because it's got to go up with a velocity. Now, as you start going up, okay, what's going to happen is potential energy is going to increase because you're getting more height, but kinetic energy is going to decrease because you're slowing down. So once you reach the top, you are purely potential energy and 0 kinetic energy. Now, as you start going back down, okay, so what's going to happen is kinetic energy is going to start going back up because you're starting to speed up again. And potential energy is going to start going down because you are starting to lose that height. And then whenever you do reach the ground, now you no longer have height, so you have 0 potential energy, and then just purely kinetic energy. So we didn't lose or gain energy, we're just shifting back and forth between potential and kinetic. So next example, it says, what velocity would an object hit the ground if it is dropped from 9 meters? Okay, so I'm going to do a little drawing here. So I have my ball and I'm going to drop it until it hits the ground, and my height was 9 meters. So this is point A, this is point B. So at point A, so let's go ahead and do our PE plus KE equals PE plus KE. So at point A, I'm just holding the ball at 9 meters high. I'm not doing anything with it, so it has potential energy because it has height, but I haven't dropped it yet, so I have 0 kinetic energy. So you can go ahead and mark that off. Now, when you hit the ground at point B, I've lost all my height now, so potential energy has gone to 0, and now it's purely kinetic. So this just becomes a PE equals KE. So we can go ahead and don't worry about the mass part, so we're just going to do gravity times height equals 1/2 v squared. So gravity is 9.8, my height is 9 meters, equals 1/2 v squared. So get v by itself, then square root. So I get 13.3 meters per second downward. Or you can put negative, either one. And that ends up being your answer. And that is it for page 29.